Our next speakers and the next topic is completely different to the first one, in case you've been in this room before, or the previous speech. This time we're going to focus on cloud. And you could argue that everyone has already adopted cloud these days, but we're going to talk about malicious actors actually using this. In this case, to make sure that they are stealthy, but at the same time, there's probably some other pairs of eyes watching them, and that's the story that the guys will share with us. So please welcome on the stage Daniel Lunghi and Jaromir Horejsi.
So hi, I'm Daniel. This is Jaromir. So we both work for Trend Micro, and we'll present our research we called abusing third-party cloud services in targeted attacks. So this is the outline of the talk. So after a quick introduction, we will discuss the standard way of how a malware operator can set up his infrastructure. We will compare it to a second approach, which involves using a cloud service provider. After that, we will show you some APT cases that we investigated lately that use this second approach of using a cloud service provider. So for each of those APT cases, we will present how the malware works, so how they use this cloud provider. And then we will point out all the advantages and disadvantages for the attacker of using this approach. So this topic has already been discussed in the past. Here, 4 years ago, for example, there was a talk named CNC as a service. But we believe what we will show today is more recent, maybe newer, and also we have other insights that we want to share. So first of all, this only is focused on targeted attacks, so no cybercrime here. And we have two goals for you two takeaways from this session. Well, we want to show real life cases, so this is from in the wild. And the most important takeaway would be how us as Defender can leverage this approach of using cloud services providers. So when a malware developer writes his malware, he wants usually to control it and sometimes exfiltrate data, send commands. So he needs a communication protocol. So the standard way of doing it is usually they will make all by themselves. So this means renting a web server, buying a domain name, so pay for the data storage, sometimes for the bandwidth. So all of this has costs, like financial costs for the attacker. But also, and maybe more importantly, it's time consuming. So first you need to design your communication protocol. So you want to think, do you want to use encryption, or do you want to use, I don't know, some lame XOR key or something, whatever. But so you think about it, and then you start writing the code. So you implement it in the language you like. And then, as nobody is perfect, you need to test it because you want it to work when you use it in the wild. So this takes a lot of time. And on top of that, you need to install the operating system on the server side, configure the web server, blah, blah. So this is very burden to the threat actor. And also it has a lot of disadvantages because, for example, if any security company will publish a report on your group, then any IT administrator can take the IOCs, search for that on the logs, and maybe find that they are compromised. They can block it also easily. If you're a security researcher, maybe you can sinkhole the domain names. Or even if you're law enforcement and it is happening in your country, you can seize the server. So this is not very good for the attacker side. Also, as you are the one who developed everything, there is higher probability that you made some mistakes, and that can be leveraged by security researchers, for example. And also, it's harder to assess how reliable will be your protocol before actually using it. I would say the only advantage I see of using this standard communication protocol is that you can do whatever you want. I mean, as you are the one designing it, you can do whatever you want. On the other side, this cloud approach has other advantages. So you don't need to develop anything. You don't maintain the server side. And all of it is done by a third party that actually is good at this topic because it's their work. So you don't get to do all this work. It's cheaper. Most of the time, actually, it's free. Most of the cloud providers give an API. It's more reliable. And last but not least, it's harder to block because if you're an IT administrator, you see a request. Maybe your company is using Dropbox or GitHub for legitimate purposes, so you cannot block it easily. And if you see a request to GitHub, how will you know if it's legitimate or malicious? So this is, for an attacker perspective, a good idea to use cloud. But of course, you are constrained by the API features. So let's talk now about more specific cases. So the first APT group that we'll discuss about is named Patchwork. So here in red, you can see the targeted countries for the non-targeted countries for this group. As you can see, it's mainly Southeast Asia and US. So we'll talk about one specific malware called Badnews. It's a backdoor that actually uses both of the alternatives. So it will use a cloud service provider that can be GitHub or WordPress, for example, to do a GET request to the cloud provider and to get an encrypted CNC server. And then once it decrypts the CNC server, it will connect to it. So actually, it has all of these advantages also of the standard way. I think the only advantage for the attacker is that it can change the CNC without recompiling the binary and without having to reinfect the victim. So if the CNC gets blocked, they can change the GitHub, for example, page and get a new CNC. This is what it looks like when you look at the sample. So it's kind of obfuscated strings that you can deobfuscate, and you get the direct cloud provider URL. If you go there, you will get this kind of pages. So this is GitHub. You see some XML content with a long base64 encoded string. The same for WordPress or for feed43. So this is what you will get. And if you base64 decode it, you still need to write some script because there is some additional encryption based on XOR and ROLL. Maybe sometimes Blowfish for newer versions, but in the end, you get a usual CNC, which is some PHP script, usually without domain name, direct IP address. So from a researcher perspective for us, what is good here, this is an example of one of the GitHub's repositories for one of these malware samples. And you can see here at the beginning, there was an encrypted CNC. It was this domain name. But like 2 days later, it got changed to another IP address. And again, got changed to the same IP address. I don't know why. But so for us as researchers, it's good because we can see the evolution of this CNC address use from the attacker just by going to GitHub. So, and better than that, we can use the GitHub search engine, and with a specific query, we can actually get all of the CNCs used for this malware family just by requesting some easy query. So here, as you can see in this page, there are 64 CNCs for this Badnews malware. So with only one sample, you get the whole CNC infrastructure for this threat actor. So now let's discuss another threat actor called Confucius that targets Pakistan, mainly government and military entities. So we will discuss one stealer named Swissknife. So it's a file stealer, so it will search for some specific file extensions like documents, Office documents or PDF files. And it will upload them to Dropbox by using an API key in an authorization header. So this is the compiled code from this sample. So as you can see on top of it, there is the API key, and then the folders that will be seen by the malware. What we can do as researchers, again, is write this like very quick and dirty script in Python using the Python library for querying Dropbox. You can just copy-paste there the API key. And if you look in the documentation, there is some fancy stuff that you can do. There is some Boolean, for example, that allows you to include the metadata of the deleted files in Dropbox. So that was interesting for us because in this case, the attacker, after retrieving the files, would delete them. But we could enumerate the deleted files. So this is an example of what we got. So it's good for researchers because then we could have had a better idea of the interest for this specific threat actor. Again, we could also enumerate the name of the folders, deleted folders, and it was also interesting because in this case there was one folder per victim, so we could get also some victim names. So this is interesting also use case for us. Another stealer, which we call pCloud. Well, I will go quickly because it's exactly the same as Dropbox. It's also a file stealer, same extensions. The only difference in the library is that it uses the mail address and the password for connecting to, there is no API key, it's directly the credentials. So this is the decompiled code. You can see on top the mail address and password of the attacker. And we could use it to connect to the interface of pCloud. And there is an interesting here button that is named restore. So this was also nice because we saw that this attacker actually deleted sometimes the folders probably after retrieving it. So we could go to the trash and look at them. And we saw one specific folder that of name was different from the other computers there. So we restored it and get the content. And it was very interesting because actually we found out it was the attacker's machine. So probably the malware operator tasted the malware on his own machine and then deleted it deleted the folder on the cloud. So this is one of the files that we could retrieve. So we found it interesting. On the left, there is the name of the malware families that are used by the threat actor. So this is not some AV that found these names. And you can see that they will test their samples against multiple antiviruses. So as any threat actor would do, but you have this file that proves it. Another file that we found that was of interest is this Excel file that had some statistics for each victim. And on the bottom, there is one interesting note. There was note 1 Indian. So this means that this threat actor will check every hit they get, and they will compare, look at the IP address and look the country of origin. So this gives more information about the threat actor, so it's useful. The same threat actor again, but this time is another backdoor that was targeting the Android platform, so for mobile phones. How it worked, it had a CNC server. So it registered to the CNC server first when it gets infected. And then the CNC server would send commands to the application. And actually, one of the commands, it can update the AWS credentials. So this is because the AWS was used for exfiltrating files. So when the attacker wanted to copy some files, they would get copied to AWS. So with the AWS access key and secret key. If the command was to retrieve SMSs or contacts or call logs, those would get sent to the CNC server. So what was here smart from the attacker is that those keys were not hard-coded. So with the sample, you cannot extract the keys and go to AWS and get the content. It was not that easy. So this was smart from the attacker. This is what the code looked like for the function for updating those credentials. On the bottom is the function to send the files to the LWS. But still, this attacker made some silly mistakes, basic security mistakes. So we could access their panel. And this is what the panel looks like. So you can enable, disable some features. So it's definitely an espionage application for targeting mobile platform. And then in this panel, you could find the AWS credentials. So we still managed to access them. And again, we could see that they infected one of their own phones to probably test again the malware. And so we found some interesting screenshots. This, for example, is one screenshot of the WhatsApp application. And we saw that the operator was talking to some person in Urdu language. So we searched for this phone number in Facebook, and we could see that it's someone working at Pakistani Air Force. So this gives information about the kind of targets that this threat actor is interested in. So this was nice for us to see.
Okay, now I will continue with another threat actors. So this threat actor, which I introduce now, is called Muddy Water. We have been researching this for quite some time, and all what we know is that this threat actor is based in Middle East, and as you can see from the list of targeted countries, they are mainly targeting also another countries in the Middle East. This threat actor has several different custom-made backdoors, and for the purpose of this talk, we choose the backdoor called Cloud Stats, and the flow of the data of this backdoor is like in the schematics. So you have the malware, and it infects the machine, and then it uploads the file with extension .rec, like for registering the new victim to the cloud storage. Then, if the threat actor wants to execute some command, they will upload .file with .cmd extension. Then this malware will read it, run it, and puts the result into .res file and uploads the result back to the cloud storage. And from there, the threat actor can read the result of the command. The name of each victim is of course different, and in the purpose, or in case of this malware, it used like different like environment hash, so the threat actor could distinguish between like different victims connected to the same storage. So when we did the reverse engineering of this malware, so from this piece of from this source code, you can see that it was written in PowerShell, and this is the function read file. And for us as researchers, we care mainly about this information, like headers at authorization variable, and also like the URL. The same for upload. There is the URL, and again, some authorization variable. So when we go farther and look more into the like decompiled source code, we can see that there are like some variables like $API, starting with bearer something. So they're like hard-coded API keys, which can be like very useful for us. Here is the screenshot, again mentioning all the different extensions which the malware is using. So if we know all this information, if we know the extension names, if we have the API keys, we can write our own scripts which will regularly monitor the content of this cloud storage and download like all the files for us. And we can get like the files like this one. So this is the example of the registry file. So you can see that there is the name of the machine, there is the architecture, there is domain name, there are IP addresses. The example of result file, hex encoded, but after decoding, you can see that they run the ls command for listing content of some directory. It's like very, very interesting for us. Like we can know what's going on, we can monitor this threat actor on time. One more piece of malware I will talk related to this muddy water threat actor. It's like one mobile application which was interesting for us because it used Telegram channel for exfiltration. So when the phone was infected, so it registered to the standard CNC server, and threat actor could control this infected mobile phone, but the stolen information were uploaded to the Telegram channel. So for us as researchers, we did some reverse engineering, and you can see that there is like hard-coded URL to api.telegram.org, and then also you can see like another information like chat ID or bot ID. You can go farther and you can explore like what are the implemented like backdoor commands or process commands. So there's the function process command, again with hard-coded links to some Telegram API. For this, in this case, like what was done, what was quite interesting feature or useful feature, if the threat actor loses the control of the CNC server for whatever reason, and then the mobile phone is still infected, there was the function that once a day, it just collected all the data, like system information, list of contacts, SMSs, call logs, and uploaded them to the Telegram channel. And there was like it was done like once a year. So even though they couldn't issue any commands, they could still get some updates, some changes at least once a day until this application got uninstalled. And of course, if we have Telegram, we can enumerate or we can see some information related to this Telegram channel. So for us, maybe interesting information or interesting metadata could be this language code, which is called FA, which is Farsi, which might give us a hint where the threat actor is coming from. Or it can be also false flag, so who knows. Another threat actor I will talk about shortly, we call him like this SLUB, and for the targets we only know that they target some people who are interested in North Korea, not necessarily living in North Korea. And this threat actor had we observed two versions of the malware, and all of them were using the combination of different services, each of them for different purpose. So in this case, they used gist for sending the commands or for giving the commands which should be executed on victim machine. They used Slack channels for exfiltrating the results of the commands. And they used file.io for uploading stolen files or uploading some bigger files. So we know that this malware was delivered via waterholing. And this is the example of this gist file, as I mentioned before. You can see that there are different commands, and only some of these commands are activated. So it starts with these two symbols, like this caret symbol and dollar symbol. So it says that the command which is enclosed between these two symbols are activated. The others are not activated, so they are not executed. And there's one disadvantage of this malware version 1, that there is only one gist file. So if there are more victims, that the same command is executed on each victim. So this is the disadvantage of version 1. It was fixed in version 2. I will talk about it later. For Slack, we are interested in Slack tokens. So the file was the malware file was executable. So we could we could reverse engineer it, and we could find that there was the Slack token split into several small strings. So when we concatenate them together, we get the Slack token. And this could help us later for writing some of our monitoring scripts to get data from the Slack, from the Slack channel. For the use of file.io, this is kind of interesting, quite good service for threat actors, because when the file gets uploaded to the service, then it's downloaded just once, and after one download, the file is deleted. So even for us researchers, when we obtain the link to the file, we would have to download it, get the link before the threat actors, because if we are later, we get no content. So I mentioned that there was version 1 in the before. There has been some improvements in version 2. So I mentioned there was this limitation with gist link or gist file. So it's not used anymore. In this case, they created the Slack workspace, and each victim had separated channel on the Slack. And if threat actor wanted to issue the new command, so they created a message which they pinned to this channel. And the victim machine just reads the pinned message from the given channel, reads it, executes it, runs it, and the result is uploaded to this respective channel. So again, the schematics, the Slack channel, file IO, plus there is one new thing, because I mentioned that they needed or they use this Slack channel and there are some tokens. So what will happen, or we as researchers can contact Slack and they can disable these tokens. So for threat actors to prevent this thing, they put there this kind of backup mechanism that there is one site which is microblogging service, and they just regularly check this content of this website, and if the content of this website matches some specific pattern, they use this for uploading new Slack tokens. So this was how the website looked most of the time. So it was empty website with some default text. But at the time when their original Slack tokens were disabled, they just created this kind of update. So there have been again some hard-coded strings, you can see here hello, what, 3 exclamation marks, and between them there are new Slack tokens. So if they need to do update, they can do it very easily. So this is a combination of 3 different cloud services. So what's interesting for us as researchers, if we think about this threat actor. So for GIST, it's very good to look at the revisions, and we can see some example like this one. You can see what changes have been made, what commands have been activated and deactivated. We can see some history. So in this screenshot below, you can see that there is some software called plusboard something, and there are some .mdb database files which the threat actor was interested in, and they issued a command to upload these files. For the Slack, if we have Slack tokens, it's very easy in Python to write few lines of code for enumerating all the users, all the channels, history of the channel. So we can do these commands. It's usually one-line command in most cases. We can get result in JSON format. It's text format, very easily readable. So here you can see the highlighted text commands, which tells you what command was executed in this case. In case of screenshots, we can get permanent links to the screenshots, to the files with screenshots, which we can easily download. And we could, for example, see this kind of example that some victim was running their machine. There is this plusboard software running in the background, some text in Korean. So yeah, it worked well for the threat actor and also for us, because we could monitor them and see what was going on. So now I'm coming for the conclusion. So this kind of abusing these cloud services or cloud service providers, it's not limited to some particular location. It's kind of worldwide trend. We can see more threat actors using these methods. So for the threat actors, it has many benefits. And the same is also for us as researchers, because we don't need to hack back. In most cases, we just extract these tokens and try to download everything. And in these cases, we have been quite successful, and it's quite fun to do this. So that's all what we wanted to say. This is the list of some references. And if you have any questions, we will answer.